So do you see now the file of problems? Guys, please, can you mute your microphones so that you will hear me well? Okay, so let us start. We will solve problems today on chapter 2. So in problem 1, we have a sensor at A that reads 1.5 kilopascal gauge. All fluids are at 20 degrees. In general, they gave us the information of temperature in order to determine the specific weight, okay? So we need a table for this. If we don't have a table, they will give us the specific weight. So here they gave us gamma of air, gasoline, glycerin, okay? Yeah. So we have here air, gasoline, glycerin as fluids, okay? And their specific weights are given. We want to determine the elevation in meters of the liquid levels in the open piezometer tubes B and C, okay? So here, this is my figure. I have my reference level at the bottom. This corresponds to Z equals 0. What I want to find is what is the height from this level to the fluid in tube B. So I will call it Z of B. Okay. And I need also to find what is the height here in the second tube. I need to find Z of C. So this is the question. Okay. Now, in order to solve for the elevation, I should relate the pressure in the tubes and in my reservoir, okay? So here, let me start with the elevation in B. I will start from point A. Why I will start from point A? Because I know that the pressure at A is equal to 1.5 kilopascal, okay? This is why I will start from here. And I will write that I will go from point A to the point of interest. I am interested in the pressure at this point here, okay? So I will write the relation between pressure at A and pressure at this point. So let's go step by step. I will start by PA. Now, from A, I am going downward in air, okay? I am going downward a distance of 2 meters in air. So my pressure is increasing, okay? So I should add to PA rho G, rho of air, of course, times G, times this height, which is 2. And I can replace rho air times G by gamma of air, okay? So I can add to PA here plus
دكتور بس شو هو PA بالضبط؟
PA is the pressure at point A. Okay? So you are imposing a certain pressure at point A and it is given. They said that the sensor at A is reading 1.5 kilopascal. So the pressure at point A is known. Okay? Since you know the pressure of point A, you can determine the pressure in other points you are interested in. So first, you start from A, you know that it is 1.5 kilopascal. So you can replace it because we will work in SI units. So it's 1,500 pascal, okay? Plus gamma of air. So plus gamma of air times 2, because we are going 2 meters down in air, okay? Now, I will continue until here. I will go down until this level here, okay? I will go down into gasoline a certain distance. My problem here is that I don't know this distance because they didn't tell me They didn't tell me what is the length from this point to this one, okay? And this might be tricky for you, but always when you have in such problems a distance that is not given, usually it will be simplified, okay? So all you have to do is to name this distance. Let's say we call it, for example, let's say you call it distance D, okay? So if you call this distance D, then you will say that I am going into gasoline a distance 1.5 minus D. So I'm going down here a distance equal to 1.5 minus D, okay? So I should, and because I am going down, my pressure is increasing. So I should add to the previous terms, I should add plus gamma of gasoline, okay, times the depth. The depth here is 1.5 minus D.
دكتور بس ليش 1.5 minus D؟
لأنه the distance 1.5 is from here to here. Okay, 1.5 is the total height of gasoline you have in your reservoir. Okay, but what you want to do, you want to go from A to this point. So you will not go down here. You will stop at this level because you want to go to this point here. Okay, so this is why you need to find only this distance and not the whole one. This distance is 1.5 minus D, okay? Because you want to reach this level here, because you want to know what is the height of the fluid in your tube, okay? So if you move from A to the tube, you should stop here and go in a straight line. So what you are going down in gasoline is not 1.5, it's 1.5 minus D. Okay?
Okay.
Okay. Now, after we are at this level, we will go up this distance. So we will go upward now by this distance. Okay? Now, who can tell me how can I find this distance? What is this distance?
Z minus D. Z minus D.
Only minus D?
Oh, no, sorry. Z minus D plus 1, minus into D plus 1.
Yes, very good. Okay, so this distance that I am going up is, I will write it here down. This distance is Z of B, Z of point B, okay, minus D minus 1. Okay, and now because I am going upward, since I am going upward, my pressure will decrease. So instead of plus, I will put minus. So if I continue here, so I will close the brackets, minus, because I'm still in the same fluid, I am still in gasoline, so it's minus gamma gasoline, okay, times ZB minus D minus 1. Okay? So in this
Gamma
way,
gas D وgamma gas will cancel each other.
yes,
D
so D here will cancel each other, so I will get rid of D. So I don't need to know what is D. Whatever is D, I will get the same result for ZB. Okay? And this is equal, this will be equal to the pressure at point B. Okay? Now, look, because they gave us gauge pressure for A, since they gave me the gauge pressure for A, I will work for gauge pressure. So PB also will be given as a gauge pressure. What is the gauge pressure at point B? Who can tell me? They said we have open tubes B and C. This means that the open tubes are
atmosphere.
Doctor, be atmospheric.
Very good. They are subjected to the atmospherical pressure. And since I am expressing my pressure in gauge terms, so it's 0. Okay? Because what is gauge pressure, you remember? Gauge
P
pressure.
minus P atmospheric.
Yes. So I am putting my zero reference at atmospherical level.
Atmospheric
So
pressure.
if in a place I have atmospherical pressure, this is absolute pressure, PA. And if I want to express it in gauge pressure, I subtract the atmospherical pressure. So when I am exposed to the atmosphere, my gauge pressure is equal to 0. In this equation, I have only one unknown, which is what? My only unknown is ZB, because as we said, D will be simplified, and I will only have to determine what is Z of P. Okay? Any question on this? Okay, so now we will do the same work, but to determine the elevation in C. Okay, so let us clear everything. Let me check your chats first. Okay, Hadi, concerning air in general, when you have air with other fluids of higher density, you can neglect air. Okay, but because they already they gave you gamma of air, so take it into account even if it is negligible. So of course here you can neglect it here, because look, you can compare gamma and the elevations. The elevations are nearly close to each other, so you don't have very high elevation of air, and gamma of air is very small compared to gamma of gasoline and glycerin, so you can neglect it. But because they gave you the value and they gave you the height, so it's fine, you can put it, it will not change anything, and the change in value will be very small. But when they give you the data, it's better to use it to be accurate. Okay, now okay, moving now to elevation in tube C. So we need to find this elevation. So this is our reference line, as we said. This is our reference line. And we want to find the elevation of glycerin in this tube. Okay, so we will proceed in the same way. We will move from point A to this point. So first, as we are moving, we move first through air. So because we are moving down, the pressure is increasing. So it's PA plus gamma air times 2. Then we move into gasoline. Also, we are moving downward. So it's plus gamma gasoline times 1.5. Now, for glycerin, we will move until this level, okay? Because we want to go over the tube, okay? And here, because also I don't know what is this distance, also I will put any name for it. So let's say I will call this distance. Let's say I call this distance X, for example. Okay. So this is X, okay? And now I will write my equation. I will say that P at A, so PA, and we said that, so let me put it like this to not confuse with P atmospherical. So pressure at point A, I replace it by, it's 1,500 Pascal or Newton per meter square, plus I have gamma of air. So I can directly replace gamma of air, which is 12 times the depth, which is 2, plus gamma of gasoline, which is 6670 times 1.5, plus now I will use gamma of glycerin, which is 12,360. Now times, I should here pay attention for the depth. The depth here will be what? It's 1 minus x.
1 minus x.
So 1 minus.
بس ما دكتور الاكس حترجع تروح فليه ما بنخلص بنشيلها من الاول دغري بنحط
لانه how you can you should verify انه it will be cancelled. Okay. Okay. يعني you should make sure that
بالثير ممكن نعملها غير ثيرمو انه خلص انه بتنزل بتطلع انه خلص it will cancel each other بس انه
Yes, it's true. هلا we will do it. Yes, you can say that you can directly jump. You will see it in the other problem. But in general, when you have the fluid and you are moving down in it, then up in it, yes, you say it's directly negligible. Okay, but here it's a little bit tricky because you have you are not moving in the fluid and then going up. It's a little bit different. You have a tube, but at the end, it's true. What you are saying is true. This will cancel out. Yeah. Okay, and now we will go upward in the tube, so the pressure will decrease. Okay, and we will multiply by the height, which is z of c minus x. So the distance here is z of c minus x. So now if I continue in my expression, it's minus 12,360 times z of c minus x, and also it's equal to 0 because we said that the two tubes are open to atmosphere, so gauge pressure at this point is 0, and the only unknown in this equation is z of c. We can determine what is z of c. Okay, any question on this? So let us move. Just let
دكتور
me. Yes.
ال 1.5 كيلو باسكال على الاي ان due to what?
It can be any source of pressure. Okay, you can have, for example, a jet of fluid. You can, it can be any source. It's not drawn here.
مخصص الاتموسفيريك pressure.
No. It's different, of course, from the atmospheric pressure. So you are putting a certain. You can exert a pressure by different ways. You can exert a pressure using a plate. If you press a plate on a certain area, you can induce a pressure. You can have a jet of gas, a jet of water. You can have different sources of pressure. You don't care for the source because you already know what is the value of your pressure here.
Okay, thank you.
And don't forget, you don't replace in kilopascal because the unit of gamma is a Newton per meter cube. Okay, so PA should be in Newton per meter square. So here, in order to have same units, this should be in Newton per meter square, which corresponds to Pascal. So you replace PA by 1,500. Okay, because your gammas are given in Newton per meter cube. If gamma is given in kilonewton per meter cube, then you replace PA by what?
By kilopascal.
By kilopascal. Okay, so pay attention to have same units over your equations. Yes, Rawad, I will repeat the gauge and absolute pressure. Okay. So for gauge and absolute pressure, you have an absolute reference. Okay, what is the absolute reference of pressure? When you say absolute pressure of 0, this means that if you go below this level, you will have vacuum. Okay, so the 0 absolute, this is 0 absolute pressure. If I go below it, okay, I am in vacuum. So below this pressure, I am in vacuum. Okay. Sorry, 1 second. Yes. What I want to tell you is you have the 0 absolute pressure, you have the atmospherical pressure. Okay, so the atmospherical pressure is known, it's nearly equal to 1.3 bars. Okay, so you have the atmospherical pressure that you can measure. In general, sometimes because the atmospheric pressure is widely used, okay, in case you have a value of pressure that is below it, okay, instead of saying that I have a value of pressure lower than P atmospheric, I can take that the P atmospheric as reference. So because it's a very common pressure, sometimes we take it as a reference. And we say, in this case, if I work in gauge pressure, this is my reference. So the whole idea is that you are changing references, okay? So if your reference is the atmospheric pressure, then you consider, if you consider this is your 0, then you will say that here, if this is my 0, then it's, I am counting gauge pressure from here, okay? So if you have pressure that is higher than P atmospheric, you will have a positive gauge pressure. So if you are here, if you are above P atmospheric, you have positive gauge pressure. And if you are below it, you have the negative.
دكتور هي P gauge minus P atmospheric equals 0 صح؟
He P gauge, no, P gauge minus P atmospheric equals 0? No, of course no. Look, you have any pressure.
كيف هي الفورمولا؟
Okay, الفورمولا هي P gauge, okay, is equal to pressure absolute minus P atmospheric, okay, minus P atmosphere. So in case you are at atmospherical level, then P absolute will be equal to P atmosphere and your gauge pressure will be 0, okay? The 0 absolute pressure is a pressure that you cannot go below, and you cannot go below 0 absolute pressure. It's the minimum possible pressure you can reach, okay? So, and because the atmospherical pressure, we are living in the atmosphere, and the atmospherical pressure, we use it a lot, we said that we might consider a new reference for us. Instead of taking the reference of absolute pressure as reference, we can consider that we want to express pressure reference from the atmospherical pressure, okay? So like if you have a coordinate system, any coordinate system, you can change its origin, yes or not? So you can say, I want to count starting from here, or I want to count from another level, okay? The definition of 0 absolute pressure is the minimum pressure that I can reach. I cannot go below it, okay? And this is the case, and you don't have anything, you don't have any force acting. So at this stage, while for the atmospherical pressure, if you are in the atmosphere, you will feel a certain pressure, okay? So you can express pressures or taking as reference the absolute pressure, or taking as reference the atmospherical pressure. And we consider that because the atmospherical pressure is an important reference, okay, we will come up with a new term, which is P gauge. When I give you P gauge, I am giving you the pressure with respect to the atmospherical one, okay? So if you want to find the absolute pressure, all you have to do is to do P gauge plus P atmospheric. And because P atmospheric is the reference of the gauge pressure, if you are exposed to the atmospherical pressure, what will be the gauge pressure in this case? It will be 0, because if you are P gauge, so we can write that PA, P atmospheric gauge, is equal to P absolute, okay, minus P absolute of atmosphere. What is P absolute of atmosphere? It is P atmosphere minus P atmosphere equals to 0, okay? So a gauge pressure of 0 corresponds to the atmospherical pressure. Now, we say, if you want, that when we talk about vacuum, our reference in vacuum is the atmospherical pressure. So if I am below atmospherical pressure, I have suction effect. Okay. So when you have negative gauge pressure, it is the case where you have a vacuum. And when you have positive gauge pressure, then in this case, you have increase in pressure of your atmosphere. So you are putting an additional source of pressure instead of doing vacuum. Okay. So we can say that negative pressure, so when you are below P atmosphere, I have vacuum. Okay. Is it clear? Okay. So okay, so let me go to another problem. In the following figure, determines the variation in pressure between points A and B. Okay, here I have the following system, and I am moving from point A to point B, and I have several fluids. Okay, I want to find the difference in pressure between A and B. So I am interested in PA minus PB. In such case, I will follow the track, the path from A to B in order to find a relation between PA and PB. Okay, so let us start from point A. So I have first P of point A. Okay, now starting from A, I am going down in mercury. I am going, first I have benzene, then I have mercury. So in a first step, I am going down into benzene. Okay, so I should add, so it's plus gamma of benzene times, don't forget to transmit your units. So because gamma is in Newton per meter cube, so I will use H in meter. So it's 0.2. Okay. Now here you can use what we call crossover. Okay. So here, as your friend said in the previous problem, I'm going down into mercury, and then I'm going up the same height. So I can skip this part. I can directly cross over from this point to this one because I am moving in the same fluid. Okay, because I will go the same distance down, then move the same distance up. So no need to consider this part. I can directly only account for this part. Okay, so in mercury, I am going upward, so my pressure is decreasing. So I will do minus gamma of mercury times, what is the height I'm going up? It's 8 centimeter. So it's times 0.08. Okay. Now I am in a new fluid. I am moving in kerosene. So first I will go here. I can do crossover. Okay, because it's the same fluid. So I'm going up in this fluid and then going down. So I only need to account for this part. Okay, I am going upward a certain distance. What is this distance from this point to this one?
32.
32, because they gave me that the whole length here is 40, and I should subtract from it 8. So I'm going here up a distance of 32 centimeters. And I don't care for the length of this part. This is why they didn't give me this length, because I'm going up and down. So it will cancel out. I don't need to know what is the length here. Okay. Now I cross over and I reach this point. Okay. So let's first add it to the equation. So because we are moving upward, so it's minus. So it's minus gamma of kerosene times 0.32. Okay. Now, as I reach this level, Okay. I am going now into a new fluid, which is water. I am going from here to here. Okay. But also here, I can jump from this, when I reach this point, I can directly cross over to this point, because here I'm going down and then going up into the same fluid. Okay, so I am only interested in this part, in this length from here to here. Okay, in order to determine this length, I'm going down a distance of, I have that the height, here the height is 40, okay, and I have that the height here, okay, is 14 centimeters. So I have 40 minus 14, which is 26. And since I'm going down, it's plus, okay? So I will add plus gamma of water times 0.26. Okay, now as I am here, I am going up into air now. I'm going upward 9 centimeters, so it's minus gamma of air times 0.09. Okay, and it's equal to PB. And what I care for is the difference between PA and PB. So all I have to do is to say PA minus PB is equal to, and I do my calculation, and I find the pressure drop between A and B. Okay? Any question on this problem? Okay. So let us move to another problem. In the following figure, both the tank and the slanted tube are open to the atmosphere. If the length L is equal to 2.13 meters, what is the angle of tilt phi of the tube? Okay? So here we need to find what is the tilting angle phi. In order to do this, we will relate pressures at these 2 points, here and here. While we do this, because these two levels are exposed to the atmospherical level, so we know what is the pressure here. The pressure here is P atmospheric. Okay, and also as because it's an open tube, also the pressure here is also PA. Okay, since I know the beginning and the pressure at the end, so I can relate pressures from this point to this one to find my unknown. My only unknown in this problem is angle phi. So let us start moving from this level. So I can write that I start by P atmospheric, so PA. Now I am going down into oil, and they gave me the specific gravity. When they gave you the specific gravity, okay, you multiply this specific gravity by rho of water at 4 degrees. Okay, so this is a property you should know. You multiply it by 0.8, you get density of oil, and then you multiply by G, you get gamma, because gamma of oil is rho of oil times G. Okay, if you do the product, then you will obtain, if you want also, when they give you the specific gravity, you can write this. You can write rho of oil is equal to specific gravity times rho of water at 4 degrees. Okay, and the same for the specific weight. Okay, because what is the specific weight by definition? So you can do the same relation for gamma, because to go from rho to gamma, all you have to do is to multiply by G, which is a constant here for the same problem. Okay, so I have, I can write that gamma of oil is equal to the specific gravity times gamma of water, okay, times gamma of water. And gamma of water at 4 degrees is 9,790. I multiply it by the specific gravity, I get gamma of oil. So this is this term here, 0.8 times 9,790 is gamma oil. Okay, so this is gamma oil times the depth, because I'm going down, so I do plus, I'm going down 50 centimeters, so I multiply by 0.5 meters. Also, please pay attention for units. Now, I'm going down into water. So, of course, because it's water, so here I'm considering, they gave me a specific gravity of 1. So I add gamma of water times 0.5, which is the depth. Now, for the inclined tube, I'm going upward, okay? And please pay attention for pressure variation. I don't care about the length. I care about the variation in height, because if a fluid for the same horizontal level, I don't have variation in pressure in a fluid, okay? In a static fluid, of course, okay? So now we are dealing with a static fluid, because in this chapter, we will deal with static fluids and for fluids moving in rigid body motion. In rigid body motion, it becomes different if you have acceleration. If you have acceleration, the pressure will change also in the horizontal level, if you are accelerating in the horizontal direction, okay? But in this problem, it's static, so I don't have variation in pressure in the horizontal direction. I only have variation in pressure into the vertical direction. So I care only for the change in elevation. And here, since I'm going upward, so my pressure will decrease. This is why I put minus, and I'm still in water. So it's minus gamma water times the change in elevation, which is L sine phi, okay, equals to PA.